So now we want to deal with trusses. We want to deal with trusses. Trusses are structures that are not really carrying bending moment. Even though some trusses have element of bending moment, the assumption that there is normal force that is in the members of a truss is still accurate to a very high degree. So we take it that there are the forces on the normal in the members of the trusses are normal forces, that they are not, there's no bending moment. The bending moment is very, very negligible in the trusses. We find trusses in roofs of buildings, we find trusses in bridges, we find trusses in other areas, even things that look like trusses, like towers, like GSM masts that are kind of put in a cage kind of trusses. So we find trusses in several areas. Knowing how to analyze a truss, because that's the only way you can design the truss. You have to analyze it first and get the stresses, the forces in the members before you can design the truss. So there are about 3 popular methods of analyzing trusses. The one is the method of joints. That is considering the joints as I've broken the joints here. You consider the joints. The next one is even when you broke the joints, you consider a parameter we call tension coefficient. We are going to go to that. Then what we'll do with tension coefficient. The next one is by taking bending moment. We call that method of moment, to get the forces in the members. If it's well done, you will get the same values as the forces in the members and design the members. So this time we are going to analyze this truss using the method of joint. Or joint method of joints. So in this method, what we do, just like any other method, we first of all get the reaction at both ends, at B and C in this case. When we get the reactions, we now cut each of the joints. The first joint to cut is joint B. You cut here to have joint B, because that is the joint that has a clear value of the reaction that we know. We can move from it. When we finish joint B, we move to joint G. As you'll be looking at the structure or the truss and see the joints that are easier for you based on what you have already gotten, that will enable you get the remaining value, the remaining members. So here, after joint B, we go to joint G, because by the time we're coming to joint G, we have gotten BG already. So we're left with BF and GD, and from the way the structure is positioned, you see that GD will be equal to BG, so it's already done. I won't go to F if I have not done this, because it's simpler to come to G. After G, then I go to joint F. By then, I have gotten GF. I've gotten GF, so, and I have BF already. So what is remaining is FA and FD. So I can get two simultaneous equation and solve it and get that. So the next I go to A. If I finish joint A, then what is BF is something as EC. FA is something as AE, because of symmetry. The truss is symmetrical. It's symmetrical, so mirror image. What is there is what is there. So if I can get one side, I've already gotten this. So to start, I want to start from joint B. Look at joint B. I brought joint B and created vertical and horizontal axis, Y and X axis. I created the axis so that we know that the system is in equilibrium. The vertical forces are equal to 0. The horizontal forces, total horizontal force, are equal to 0. So that enables me to create an equation. It's simple. So now let me start. Before I go to this, let me now get the reactions. To get reaction B, I take moment about C. Total moment about C equal to 0. So I start the reaction A, B from C. The length is 3 times 4, which is 12. So 12 for RB vertical. 12 RB vertical, turning this way. Then the next force is 6 that will create bending moment. minus 6 times the distance is 9, minus 8 times the distance is 6, minus 6 times the distance is 3 equal to 0. So with that, I have RB equal to 10 kilonewtons. I have RB vertical equal to 10 kilonewtons. So the next one is I find RC vertical. I take moment about B, total moment about B is equal to 0. I have the same way 12 RC vertical minus the first one is 6 times 9 minus 8 times 6 minus 6 times 3 equal to 0. So the same way RC vertical will give 10 kilonewtons. So if we look at the load to check whether we made a mistake, we have 10 plus 10, that is 20, and 6 plus 8 plus 6, that's 20, so we didn't make mistake. These are the reactions at the two ends. So since I've gotten the reactions, the next one is that I bring it to this cutting support B, that's cutting joint B. Here there is this 10 that was reaction B. So what I do here is vertically, I look at this vertically, I have force BF. I resolve it vertically, it will be BF cos 45. Because that's the only vertical force. Then the direction is up, and the direction of 10 is up. So plus 10 equal to 0. That means BF as a force is equal to 10 minus 10 over cos 45. So BF, from there BF, I got BF to be, BF become equal to minus 14.14 kilonewton. BF become minus 14.14 kilonewton. That is what I got force BF to be, force BF to be. So you see, I've gotten the force in the member BF. I've gotten the force in the member BF. So the next one is to get the force in the member BG. To get that, I had to sum horizontal forces. That was equal to 0. So the first one I have is, one of the horizontal forces is BF cos 45. So BF cos 45 this way plus BG. BG is horizontal, so it doesn't need the resolution any longer. It's already horizontal. BF was not horizontal, it's inclined, so we bring it to horizontal by multiplying with cos 45. So plus BG plus BG, that gives equal to 0. So that means BG is equal to minus BF cos 45. And we have gotten BF to be minus 14.15. So 14. So minus 14 plus 14 times minus cos 45 will give us positive. So you give us positive. So BG, we got BG equal to, BG was going to be equal to 10. BG was going to be equal to 10. BG. So BG force BG was going to be equal to 10 kilonewton positive, because minus times minus positive. So with this, we have gotten the forces in member BF and member BG. Then the forces in member BF and member BG. So the next one I need to get the forces in now is that I move to joint G. I join G vertically. You will see that vertically BGF is already vertical, so it doesn't need any resolution. So I have GF. There's no road, there's no force under it. There's no force. So vertical is only GF. So GF is equal to 0. GF, there's no other load. There's no other load for them to sum as vertical forces. So GF is equal to 0. Look at it. So the next one is GD. GD is already horizontal, so it doesn't need resolution. GD, from there, GD minus G minus GB. Already I have BG. BG is GB. BG is GB. And I got BG equal to 10. So this minus GB minus GB, horizontal, minus GB, GD minus GB, and BG is 10. It was 0. So that means GD is equal to 10. Because it was 10 kilonewton. GD. So that means GD is equal to BG. So GD is, so I've gotten the force in member GD, gotten the force in member BG, gotten the force in member BF, gotten the force in member FG. So what remains now is to get the force in member FA and FD. For me to do that, I come to joint F. At joint F, look at the forces in joint F. So the next thing is I resolve again vertically and horizontally. I resolve vertically and horizontally. To resolve vertically here, I have force FA. Force FA cos 45 vertically. Force FA cos 45 minus 6. 6 is the look at the force. 6 is pointing down, so minus 6. Then minus force FB. Force FB. I have already BF. Minus force FB is minus and another minus. So it will now be plus 14.14 minus force FB cos 45 minus FB, that is minus FB and minus FB is minus already, so it comes to plus FB cos 45. FB cos 45. Then minus FD, which I have not found, so minus FD cos 45, FD cos 45, minus FD cos 45, minus FD cos 45, which other one is not there, minus FD cos 45, then FG is equal to 0, so it doesn't come in. FG is equal to 0 already. FG, look at it, is equal to 0. So I've captured the whole forces vertically. FA. Then so I have two unknowns, FA and FD. This is equal to 0. FA and FD. So I get the horizontal. I get the horizontal equation. This is the vertical equation. Vertical force is equal to 0. Look at it here. Then I get the horizontal forces. I resolve horizontal forces equal to. So I get two equations, two unknowns. I have two unknowns here, two equations. So horizontally, I have FA. FA cos 45. Yes, just like I have it here. FA cos 45. We're talking of horizontally now. Then another horizontal value is this. FA cos minus FB. And we have FB already. FB. So minus FB again. So it comes to plus 14.14 cos 45. Cos 45. That's horizontally. Then this FD. Then FD minus FD minus FD cos 45. FD cos 45. So we are the two unknowns equal to 0. The two unknowns now is FA and FD. If we solve these two equations simultaneously, if we solve the two equations simultaneously, I have the full solution. If I solve the two equations simultaneously, I'm going to get FA is equal to 9 minus 9.8898 minus 9.898 kilonewton. FA is equal to minus 9.89 is equal to minus 1.898 kilonewton, while FD was gotten to be equal to minus 4.243 minus 4.243 kilonewton. So I have gotten FA and FD, the force in FA, and I've gotten the force in FD. Now, almost everything has been, the only thing remaining now is AD. For me to get AD, since I have even FA, I cut joint A. Look at joint A here, where I cut joint A. So at joint A, let me get off the moments I've taken, which you have taken root of it. So at joint FA, I have vertically, I have 8. 8 is pointing down, so minus 8 is vertical, minus 8 minus FA cos 45, and we already have FA cos 45. Look at it here. If we have FA already, minus, so it becomes plus 9. That's FA 9.898 cos 45 degrees. Then that's this. Then FAD. Okay, AD is what we're looking for. So minus AD. AD is vertical, so it doesn't need resolution any longer. Then AE. AE is something as F. It's something as FA. AE is something as FA. Look at FA and AE. FA is something as, so minus AE, which in AE cos, so which is plus again, because it's minus here. 9.898 cos 45 is equal to 0. So one equation, we're looking for only one unknown, as a matter of fact, because the other ones are known. AD is the only one we are trying to get. We're trying to get only AD. So if you solve this, if you solve that equation, you have AD equal to 5.997. AD was gotten to be AD equal to 5.997 kilonewton. AD was gotten to be equal to 5.997 kilonewton. So you see, all the forces in the members have been gotten. All the forces, this member can be designed. The BF is something as EC. FA is something as AE. So we've gotten FA, that means we've gotten AE. We've gotten BF, we have gotten EC. We've gotten FG, that we've gotten EH. We got FD, we've gotten ED, and we got AD. So all the members of the trusses, the forces in them have all been gotten. So with that, you can now design the truss if you wish to. We've gotten all the forces in the truss, we're able to get the reactions, and using method of joint by joint, we were able to get the forces in the members. Just divide the, and then you get the reactions, you divide the trusses into joints. Starting from the joint of the reaction, you now start resolving forces both vertically and horizontally. You will be able to get the forces in all the members by method of joint. Thank you very much.